This is the part 1 in the geometry module, and these are the 3 topics I am going to cover in this video. The file menu contains options related to file management and operations. The edit menu contains editing related and manipulating the geometrical model. And view contains options for controlling the display and visualization of the geometry. And these are the common functions found in the file menu bar. So here we will explore the tools in the geometry module. This is the standard. So here this is the modules toolbar, and we can select modules from here. So we are in the geometry module now. And you can also select modules from here. From the list we can select the modules. So from the new menu bar select view, and from here we can also select the modules. From the file menu I'll select save as. The save as option allows you to specify a new name and location for the current project or document. So it creates the save as file, creates a separate copy of the project with a new name or location, and while keeping the original file unchanged. So this option is useful when you want to create a duplicate or save a modified version of the project without affecting the original. So here I will change the file name to study 127 and click on save, and the file is saved. Now I'll select the next one, save. So the save option allows you to save any changes made to the current project or document without altering its name and location. So if you have already saved the project before, and this option overrides the existing saved version with the latest changes. So I'll select the next one, open, and we have the control key, control press O to open a new file. So here from the location I'll select this study 127 and click on open. This will open the study. As you can see, before I have saved a file with a geometry box and cylinder. So here we need to switch to geometry module. So here I'll select the next one, view. So this prompts a dialog box whether we would like to save the changes or not. So if you want to save the file, click on yes, or if you want to discard and open a new Salome window, click on no. And this is the new Salome window. So from here you can switch to modules and start a new file. So here I'll select the import option. So here you can import a file in web, step, IGS and HTML and Java formats. So here I want to import a step file. So here I select this step, and once a dialog box is prompted here, so here you can choose the file you want to import. So here I'll select this file and click on open. So you can see the file is imported in the geometry module, and it also appears in the object browser, and from here you can manipulate using various tools in the object browser, and you can modify this. So from the object browser, I'll select the revolution and select properties. So this option displays the properties of the currently selected object. And in Salome Software, the object's creation time is typically not recorded or displayed. So when you import a geometrical object into Salome using import option, you can find out the object's creation time by checking the file properties. The creation time of the file may give you an indication of when the geometrical object was created or last modified, and the version used. So the next one is preferences. This option is used to modify the preferences, and it includes settings such as units, time, measurement, and appearance of the software interface, and the default file paths, and various other options related to software. And you can also set color, line, font, and width size, and length of arrows here. And here are the modules. So here we are in the geometry module. So after changing the settings, click on apply button to save the changes, or to end, click on close. So here we have the dependency tree, and we can set the background color and default node color from here. Here I'll select the next one, most recently used, and this shows me the most recently used files. So here this is the one. So here if you want to exit the window, click on exit, or you can also select Ctrl Q key. So click on OK to end this window. So here we have the standard toolbar. So in the standard toolbar we have the tools to open a new document, and open a document, and save as document. And from the edit menu bar we have copy and paste tools. So you can either select these tools from the file menu bar or standard toolbar. So here I will select the box and click on copy, and this copies a new file. And here if I select paste, and new file is created. So here I'll select this vertex and click on delete, and this will delete the vertex. Click on S. So the next one we have toolbars. So this is the standard toolbar. So you can right mouse click on the menu bar and select these tools, or you can simply select from the view. So this is the modules toolbar, basic toolbar, primitives toolbar, boolean operations, generation toolbar, transformation, operations toolbar, modifications toolbar, build toolbar, and this is the inspection toolbar, and this is the pictures toolbar. and this one is the blocks, and the last one we have advanced toolbar. So these are the different toolbar. Now I'll select the next one, Windows. So here we have Python console, object browser, help panel, and the information, text, and the notebook. So I'll select the status bar. So this is the status bar. So here I'll select the next one, Python console. Python console creates complex geometries by writing scripts that generate shapes and curves based on mathematical equations or other parameters. So here I'll write something like Python, and from here you can execute. So here I'll select the next one, object browser. So in the Salome software, object browser is a panel. It displays a hierarchical list of all objects that are created in the geometry module. So this includes shapes, curves, points, or other objects, and which is used to construct 3D models. The help panel provides contextual help for different command and tools available in the geometry module. And here we have the import and export options. So we have different file formats. The next one is information tool. This provides detailed information about the geometry and topology of objects in your model. So here I'll select this object box, and it displayed me the coordinates for the box. So this tool is also available in the inspection toolbar. The next one is notebook. So by writing Python scripts in a notebook, you can streamline your workflow, and this creates more advanced and customized geometry models. So here for the variable, I select A and I enter a 25 value for that. Similarly, I'll set B and 7, C, 5 and D. So here I want to remove the variable D, so click on it and remove, and this will remove. So here click on update study. So you can see the study is updated as Python scripts. The next one is full screen. This option is used to expand the software's display, and this shows the entire screen. So here we have different display modes, and if we select show all, this will show all the geometrical entities. So if we select hide all, this will hide the all geometrical objects from the view. So the next one is publish. This function is used to export the geometrical model to a file format, and that can be used by other software applications. So we have different tools. So the first one is catalog generator, then the registry display, and we have materials library here. So we can set material to the object. So the next one we have plugins. This is the Salome shell session. So here we have different windows. So here I'll select the new window. So this is the GLC. The next one, plot 2D. So here we can draw points, lines and draw splines, and we have vertical axis algorithms, and we have settings. The next one is OCC view. This is the OCC view which I will, and this is the VTK mode. Next one, QXC, and this is the graphics view, and we have Python view. So from here we can select the new and open a document, and we can save. This one is copy and paste, and we can find out, and this is the help menu. So from here I'll open a file. So this is the Python script. So here we have the option close. So to close the window, so I'll click on it. So here close all means it will close all the windows from the main menu. And we have group all, which groups all the view, and we can split the windows. And here I'll select split vertically, and this splits the windows vertically. And I'll select split horizontally, this splits the window horizontally. So we are in the OCC viewer, so that's why we have this symbol. And we have the next window, GLC. So if you want to switch to GLC, we need to click here, and we can also rename the window. So we are currently in OCC scene, so here we can set the window name. Right click on the view once, and from the menu select create a group, and this will open the group property panel. So from here you can create groups without getting to the groups from the menu bar. And the next one is bring to front. This option rewards for better viewing of complex 3D models. So it allows to bring to the viewer foreground to the selected geometrical object. The next one is clear top level state. This reverts back the original shape. The next one is point marker. So this is the point marker property panel. So we can set the type of the point from this list. So here I'll select this, and we can also scale the point. Custom means we can browse the point. So here I'll select the next one, material properties. So here we can apply the material to the selected geometrical object. So here I have selected this object, and I want to apply gold material. So I will select this and click on apply. So gold material is applied to this object. The next one is auto color. So clicking on it will automatically colors the object, and clicking on disable auto color, it disables the color. So the next one is line width. So we can set the edges line width. So here I'll select the edge width, and I'll set it to 5. So you can see the edge width is broader now. Now I'll select the next one, isos width. So I'll select the isos line width to 4 and click on OK. Now I'll select isos, and set isos parameters and click on OK. So you can see with the isos with iso lines are created. So the next one is show dependency tree. So this shows the selected objects hierarchical list. So from the sketch 2 a face is created and from the face this object is extruded and this is how the shape is created. The next one is reduce study. So from the object browser you can reduce the study. So here I'll objects to be kept will be kept and objects will be removed. So these are the objects which will be removed. So I'll click this OK button. So you can see the objects were removed. So here I'll switch to different modules from the module toolbar. So here I'll select the first one, shaper module. So here in the shaper module we can sketch and we can build geometries. And I'll select the next one, geometry module. And this is the geometry module. And I'll switch to mesh module. So here we can generate meshes for the geometries, and here we can create a mesh and we can also create submesh, and we can also create groups for the mesh. So here we can modify. So here I'll select the next one, Paravis. So Paravis is the post-processing and visualization module in Salome. So it allows users to visualize and analyze simulation results. And here we can set the filters, and we have hydraulics here, CFT and so on. So here I'll select the next module, and here this module is designed for setting up and managing different simulation cases. So here we have some modules to edit. The next one is job manager. So this module is responsible for managing simulation jobs. So it provides tools for submitting and monitoring simulations, managing computation resources, and handling parallel computing tasks. So here we can create a job and edit, and the next one is fields. So this module deals with defining and managing fields which represent physical quantities in simulations. So this module is crucial for specifying the input parameters and initial conditions of a simulation. So if I click on presentations, here we have the tools for mesh, scalar map and counter and so on. So if I click on processing, we have change underlying mesh and interpolate field. So the next one is hexablock. So hexablock is a module that aids in the generation of hexahedral, which is structured meshes. So hexahedral meshes are often preferred in certain simulations due to their numerical efficiency. So if I select document from the menu, we can upload a new document or load or save a document. So if we click on model, we have construction. So here we can add a vertex or edge, and we can also create quadrangle and hexahedron, and we can also create a vector. So we can also create pipes and cylinders, and we can also create transformations here, and we can also create groups and meshes. So here I select the next one, hi hello. iHello is like a sample or tutorial module designed to showcase how to use scripting within Salome. So Python scripting is often employed to automate repetitive tasks or customize simulations. So if we select PyHello, we can create object. So the next module is Epicus. So Epicus is a module that assists in this creation and management of simulation workflows. It may include tools for script generation and automation of simulation processes. The next tool is Edevo. So it is another module in Salon, but without specific details. It's unclear what functionalities it covers. So it may be related to specific simulation or analysis tasks. So the last one is Hello. So it could be a sample module or tutorial project within Salon. So here if I select Hello, so this is just a test of custom menu action. So we need to enter name. So here I'll type a name, click on OK. So this prompts me hello Vaishnavi. So this is the end of the video and thanks for watching.